Determine the voltage across the 6 ohm resistor. So there's our 6 ohm resistor, and what we're looking for is the voltage that resides across it when I take a voltmeter and go from end to end across either side. Now you'll notice I've redrawn the circuit. I always like to simplify my circuit down as much as possible. So I'm going to leave the 6 ohm resistor in place, so it's in parallel with the 3. I'm going to leave those two because the goal is to find the voltage across the 6. But everything else, I might as well collapse that down into a single resistance. And you'll notice on the right-hand side, I've got the 5 and the 3. Those two are in series with each other, and I've just drawn those as a single 8 ohm resistor. So I've collapsed down the 5 and the 3 into a single 8 ohm resistance. The second thing you'll notice is I know every single resistor in this circuit, and I know the total voltage. So when I skip to Ohm's law is just V is equal to IR. If I use total values, I can get my total current. So I know the total voltage at 6. I need to figure out what the total resistance is. Well, I've got 8 ohms in series with these two resistors here that are in parallel. The 3 and the 6 are in parallel with one another. So if I just look at the parallel section, I would go 1 over R parallel is 1 over 3 plus 1 over 6, and I'd solve that for R parallel. And you end up getting the parallel component of that circuit to be 2 ohms. So in other words, this blue bit, I could replace it with a single 2 ohm resistor. That makes my total resistance, our total, 2 plus 8, because those two parallel components, the 3 and the 6, are in series. Together, they're in series with the 8 ohm resistor. So we know my total resistance is 10 ohms. Now let's go back and solve for my total current. My total current will be my total voltage divided by my total resistance. 6 volts divided by 10 ohms gives me 0.6 amps. Now let's take that and run with it. Coming out of the battery, my total current is 0.6 amps. Gets to this junction right here and splits up. Part of it goes through the 3, part of it goes through the 6. Joins again right here. So that means the current flowing through my 8 ohm is also 0.6 amps. So if you look at that, I've got a resistance and a current, and I can find the voltage at that stage. So right in here, I'm going to find the voltage. I'll call it voltage across the 8 ohm. So it's going to be I total times R at the 8. So my total is 6 amps, 0.6 amps, I'm sorry. And the resistance at that point is 8 ohms. And when I go 0.6 times 8, I get 4.8 volts is across this little 8 ohm resistor. So now I'm going to switch to my loop rule, Kirchoff's voltage law. So I've got 4.8 volts right there. Now, around any given path, the voltages have to add up to the total. So I'll continue to use blue here, but here's a path. Goes down through the 8 ohm resistor and then down through the 6 ohm resistor, then through the 8 ohm resistor. I've got 2 resistors in that loop. They have to add to 6 volts. So I know one of them is 4.8 volts, so the other one has to be the remainder. So the voltage across the 6 ohm resistor, V6 ohm, will have to be 6 volts. There's my total voltage, less 4.8, and I end up with 1.2 volts. Now, I'm just going to add one little thing to check. I know the voltage now is 1.2 volts across this 6 ohm resistor. So I should be able to get the current through that 6 ohm resistor. The current through that 6 ohm resistor will be my voltage divided by the resistance. And 1.2 divided by 6 is 0.2 amps. Now if I do the other resistor, the one above it, same formula. Remember, in parallel, the voltage is the same, so it's also going to have 1.2 volts. If I divide that by 3 ohms, I get 0.4 amps. And you'll recall from Kirchoff's current law, those two currents should add up to my total, which is 0.6, because that's where it splits up. So it looks like we're good to go. So our answer is 1.2 volts.